Welcome back to Exponents. This is day 4. We are solving exponential equations again today, except today we are talking about equations with unknown bases, and yesterday we did equations with unknown exponents. So today, I can get everything going here that I need. Here we go. The first thing we need to do is express each power with an integral exponent. An integral exponent just means a positive or negative whole number and not a fraction. And the smallest possible base. Well, if I want to change how 36 looks, what I would do is write it as 6 squared. 25 is 5 squared. 3, most people will be inclined to say 4 squared, but that's not the smallest possible base I can have. I can actually have a base of 2, and 2 to the 4th is equal to 16. 27 is 3 to the 3rd. 64, again, most people would like to say 8 to the 2nd, but it's really 4 to the 3rd. 81 is not 9 squared, it is 3 to the 4th. 125 is 5 to the 3rd. Now I said integral exponent. That could also mean a negative exponent, just not a fraction. If I have a fraction, I could rewrite it as 3 to the negative 1. Same thing with 1/2 is 2 to the negative 1. I don't like how that looks. 2 to the negative 1. For number 10, that is 2 to the 3rd, but since it's in the denominator, we'd say 2 to the negative 3. 125 is 5 to the negative 2. And 1 over 27 is 3 to the negative 3. So being able to do that will enable us to be able to solve the equations. The first step in solving the equation is to get the same base on both sides of the equal sign. The second step is to set up the exponents equal to each other. Third is to solve, and 4 is to check. For the first problem, we have 7 to the x minus 4 equals 7 to the first. Now, I don't have to worry about changing my bases because they're exactly the same. So all I have to do is take the exponents and literally set them equal to each other, and then solve that equation. So for this equation, we just add 4 to both sides. So x equals 5. So to just do a quick little check, I have 7 to the 5 minus 4 equals 7 to the 1. 5 minus 4 is 1, so 7 to the first is equal to 7 to the first. For number 2, this time it's not as easy because my bases are not the same. I can't make a base bigger, but I can make a base smaller. So I can't make 5 smaller, but I can make 125 smaller. So we keep our 5 to the x minus 1 equals 5 to the 3rd. Take my exponent, x minus 1, set it equal to 3, add 1 to both sides, so x equals 4. And for a quick little check, I have 5 to the 4 minus 1 equals 125. 5 to the 4 minus 1 becomes 5 to the 3rd equals 125. So 125 equals 125. And that checks. For number 3, we have 36 to the x equals 6 to the x minus 1. I'm not going to be able to make 6 bigger, but I can make 36 smaller. And 36 smaller would be 6 squared. But I still have to keep my x power on the outside there, is equal to 6 to the x minus 1. This is a power to a power, therefore I multiply my exponents, so I get 6 to the 2x equals 6 to the x minus 1. Set the exponents equal to each other. 2x equals x minus 1, and subtract both x on both sides. So I have x equals negative 1. For the check, I have 36 to the negative 1 equals 6 to the negative 1 minus 1. Doesn't even look like a minus 1. So 36 to the negative 1 is just 1 over 36 equals 6 to the negative 1 minus 1 is negative 2. So 1 over 36 is equal to 1 over 36. For number 4, this one's a little bit different because I can't just take the 8 and change it to a base of 4. And I certainly can't take the 4 and make it a base of 8. Therefore, for this problem, we have to find a different base that they have in common, and they both have 2 in common. So if I have 1 over 2 squared to the x power equals 2 cubed to the 1 minus x. Over here, I'm going to have 2 to the negative 2 raised to the x power equals 2 to the third raised to the 1 minus x power. Now, over here I have a power to power, so I just multiply. So negative 2x equals, here I have 3 and then x minus 1. I just distribute like I would in any other problem. So I'd have 3 minus 3x. And I'm going to add 3x to both sides. So this becomes x equals 3. If I put in 3 for x, I have 1/4 to the third power equals 8 to the 1 minus 3. Well, 1/4 to the third power is 1 over 64 equals 8 to the negative 2. So 1 over 64 is equal to 1 over 64. 5 is very similar to 4 in the fact that I have a 27 and a 9, and I cannot change 27 to a base of 9, and I cannot change 9 to a base of 27. So I need to look for something smaller. 27 and 9 can both be written as 3 to a power. So this is 3 to the third to the x equals 3 to the second to the x plus 2. So I have 3x equals 2x plus 4. Subtract 2x from both sides, we have x equals 4. So for my check, I have 27 to the 4th power equals 9 to the 4 plus 2 power. This is when I say get your calculators out, because I don't know what 27 to the 4th power is. And so we need to check what 27 to the 4th power is. is a really big number. $531,441 equals 9 to the 4 plus 2 is 6. So, again, on the calculator, raise 9 to the 6th power. And thankfully, after we do that, that's supposed to be a comma. Right there, right there. We end up with the same number. So that checks. So today, instead of multiplying by the reciprocal power with solving our equations, today we are finding a common base, and then if we have to adjust it, we change our powers, so we end up with a power to a power, and we multiply that portion first, and then we set the exponents equal to each other. Tomorrow we will do some application type problems, or actually Monday night I should say, we will do some application type problems, and then we will start to do a little bit of review and probably have a quiz on looks like Tuesday maybe, and then tests probably either Thursday or Friday of next week. Alright guys, I hope you either are going to enjoy your weekend or have enjoyed your weekend, because you should be doing this on Friday night or Saturday or Sunday. So I will see you in class on Monday. Come with any questions.